In today's lesson, we're going to be having a look at the theoretical probability. The theoretical probability, it looks like it's better to be remembered as a formula. Okay, the probability of an event, in this case to be a successful event to happen, will be it will be a formula based on the total number of successful outcomes, the ones we are looking at to be successful, the probability, over the total possible number of outcomes. Okay, let's see an example because this is easier to see with an example. One thing I want you to be aware is that when you calculate in the theoretical probability, the successful event always goes in between the parentheses. Okay, so you just get the probability of, and then in parentheses, whatever you want to get. In this case, is what is the probability of getting a 3 when throwing a die? So the probability of getting a 3, how many 3s are in a 6 faces die? There is 1, okay? In a dice, not die, die is a plural. In a dice, so that's 1, 3 over 6 sides of the of a standard die. So then you can calculate that as a fraction, which is perfectly valid, it's 1 over 6. You can also calculate as a decimal, 1 over 6, and this is a repeated 6, okay, recurrent 6. And you can also express this as a percentage. This is, remember, the theoretical probability. Obviously, if your dice was in some way, somehow biased, had more weight on one side, or something like that, it could be this will change. Okay, the odds will change. Jonah, you have a question? No. Just remember that the probability of an event to happen is going to be always greater and equal than 0. You cannot have a negative, an integer there. A negative less than 0, okay? Cannot be a negative probability. And it will be always less or equal than 1, okay? Because once you reach the 100%, you cannot have 110% chances of something to happen. What you will have is 100% or 100 over 100 equals to 1, okay? This is your formula for theoretical probability. This is the one you can start with. Obviously, when we compare with the experimental probability, this will change. That you may not get the same results, and it could be a number of factors that makes you that the results are different. Okay, but we will get to see that in experiments. We're gonna do some experiments. Any questions before I move into the next example, which is similar? Good. Let's gonna have another look at another example. What would be the probability of success of getting, an ace of hearts out of a deck of cards? An ace of hearts. How many ace of hearts do you normally get in a pack, one pack of deck of cards? How many aces of hearts? 1. How many cards are in total? Do you know? Does anyone knows how many cards are in a French deck? 52 cards. So that's gonna be your probability. What is the probability of getting 1 out of 52? 1 ace of hearts over the 52 cards. You got so how do you get the percentage here? How do you get the decimal? Just divide the numerator by the denominator. If you get a calculator and divide 1 by 52, you will get 0.019. If you want to turn this into a percentage, what would you do? You will times by 100. Okay, I have the pen on. I'm just doing this with the mouse, not the script. So if you multiply by 100 the decimal, what would you get? You will get a percentage. So you just move the decimal to the right. To spaces as many spaces as zeros you get. So you will get that 1.9% is the chances. There are people in the casinos that they go on and they play a game. It's called the blackjack. Okay, the blackjack. Once they reach 21, The one that gets closer to 21, each card has a value, face value. I think the aces is 10. Is it 10? I don't remember. But anyway, they bet, they gamble, and then what they do, the addicted players or very frequent players, is that they try to memorize. They know all the odds, they know the chances. But once the card is removed from the deck, then they know that the chances of getting another say hearts diminishes or increases, depends on the cards that has been. Okay, so that's the that's how they do. They calculate, they count the. Right. Any questions regarding this theoretical probability? Everything follows the same. If it was what would be the probability of getting a heads and tossing a coin? Well, what will be the probability of getting a heads? How many heads you have? You have one head. Out of how many sides? Two. So the probability of getting a heads when tossing a coin is 1/2, which is 50%. Okay, this is that's another way of getting the probability. It's a theoretical probability. Right. Also, I want to make you aware of something that you may not be that may not remember, and this is about the complementary event. What is a complementary event? Complementary event is nothing but the probability of the opposite event. Okay, the opposite says the successful outcome, if you want to say. Okay, so the probability of not getting an ace of spades or ace of hearts, it will be the probability of every other card, the 51 cards that you got remaining. How do you calculate that? Well, this is what it says: the probability of an event to happen plus the probability of the complementary event. This is the complementary event. This is the complementary event. Is the probability of the event not happening is equal to 1. That makes sense. If you were looking at the cards, the probability of getting the ace of hearts is 1/52, plus the probability of not getting the ace of hearts, it will be 51/52. So 1 plus 51 is 52. 52/52 equals to 1. Make sense? What else? If you want to find the complementary event, what you can do is to subtract 1 from the probability of the event happening. Okay? So you can subtract, you can take away. So if you want the probability of not getting of a complementary event of the ace of hearts, you just take away 0.019 from 1, okay? Or subtract 1.9 from 100, okay? Or subtract 51/52. This is not hard. It's just the complementary event. It's the opposite. Okay, it's not getting the. It's easy to work it out. Okay, if you're not sure, just work out the probability of an event happening, and then subtract from the percentage, the 100% if you want. Any questions before we jump into the Go formative? You happy? This is the same slide, and that's for tomorrow. So let's gonna move into the Go formative. I'm gonna share with you just now on Google Classroom.